In Rosen, Discrete Mathematics and its Applications, Section 2.3, where we discuss functions. Here are the topics covered in this section. This video will cover the first bullet with its sub-bullets. All right, we'll talk about functions in two different ways. The first way will be to describe it as a relationship between two sets. We have A and B are non-empty sets, and they can be the same set, and sometimes they are, but we'll consider them different at the moment or differently named. We say a function, we'll call it f from A to B, has this denotation, f colon A arrow B, is an assignment of each element in A to exactly one element of B. And we write the function at A is equal to B, or f of A equals B, when B is that unique element in the set B assigned by the function f to the element A of the set A. Functions have a couple of other names you will encounter. One of them is a mapping, the other is a transformation, but they are all the same thing and meet the same definition. Here's an example of a function. My from set in this case is my student set, and my to set are my grades, and my function assigns a grade, a single grade, to each student in my from set. And if I had a student who did not receive a grade, then this would not be a function. And if I had a student receive more than one grade, then it would not be a function. All right, now for the second look at a definition of functions. Let's think about them as a subset of A cross B. Now, a subset of A cross B is also called a relation, which is covered in Chapter 9. But what is A cross B? Well, A cross B is a set of all ordered pairs A and B, such that the first element comes from the set A, and the second element comes from the set B. And a function is a subset of that, but it's a restricted subset so that no two elements of the relation have the same first element. Okay. So specifically, a function from A to B contains one and only one ordered pair. So it does have an ordered pair for every A element of the set A, but only one. So here's how we can render that. For every X element of A, there's a Y element of B such that XY is an F. And if there are two Y's such that X and Y1 are an element F and X and Y2 are an element F, then Y1 must equal Y2. If Y1 and Y2 were different, then we would not have a function. That would be the equivalent of a single student getting 2 grades. Okay. All right, so we have a depiction of my from set and my to set with the function, in this case, mapping an element A to the element B in the to set, or in this case, we're depicting the fact that f is a function or a transformation from A to B. So here we have a function from A to B. We say that f maps A to B, or is a mapping from A to B, as mentioned earlier. All right, these sets have names. A, the from set, is called the domain of F. And B also has a name. It is called the codomain of F. And now, when a function acts on an element of the domain, we get B an element of the codomain, then B has a name. It's called the image of A under the function. And then if B is the image of A under the function, then A is called the preimage of B. If I take all of the image points of B under F, that is called the range. The range is a subset of the codomain. We can denote it by taking a function of the domain. Sometimes the range and the codomain are the same, but um, often the range is a proper subset of the domain, of the codomain. And we say that two functions are equal not only when they map each element of the domain to the same element of the codomain, but also they must have the same domain and the same codomain. And that is your introduction to functions.